Hi everyone, my name is Priya and I'm glad I got the opportunity to share the findings of the SIGTYP 2023 share task on cognate derivative detection for low resource languages. We start the presentations with defining the cognates and derivatives for this share task. So basically the cognates are etymologically related word pairs across the languages that can be traced back to a single ancestral word form in a common earlier language stage. So, for example, the Libro Spanish and the Libre in French are considered as cognate. They can be traced back to the Liber Latin, Liber to the Latin. On the other hand, derivatives are defined as the word forms or the word pairs which are adopted into a language either from an earlier stage of the same language or as a borrowing from some other language. For example, the Levard New Iris is derived from the Old Irish Lebor, thus they are considered as derivatives, and Levard in Irish is borrowed from the Libar in Latin in some earlier or the Old Irish stage, and therefore the New Irish Liber and the Latin Liber are considered as derivatives. What are the motivation of such tasks? So this kind of task has been studied by various people in various fields. For example, the historical linguists, they started with study of the cognates and derivatives, which can be helpful in reconstruction of the proto-languages. In lexicography, it can help in multilingual dictionaries development. In the field of NLP, it can help in tasks such as machine translation, lexical induction, building the dynamic language embeddings. However, this kind of tasks such as specifically supervised cognate and derivative prediction can be very expensive as well, and as well as challenging, specifically for the low resource languages, because the supervised task really needs manually annotated data, a large amount of data, which could be a difficult task for less resource languages. For example, finding linguists and finding the annotators for low resource language is quite expensive, and it's very impractical as well. Therefore, we divided the task in two subtask category. One, the supervised cognate and derivative detections, and the unsupervised cognate and derivative detections. Now, for both the tasks, we also allowed the participants to use of other additional data sets, provided they are the data sets are publicly available, and a proper citation is given in their system description paper. The schedule of the shared task is given in the table 1. The data sets that we have used for this shared task is taken from the Wiktionary, basically crawled from the Wiktionary, and we have annotated pairs of cognate and derivatives and none. Whereas in Wiktionary, there are other categories as well, but we are not considering those categories in our data sets. The data consists of 34 languages, which includes both high resource and low resource languages, but mainly low resource languages. Now, for the test data, we used the same Wiktionary data, but they were manually annotated using the Wiktionary templates. The data statistics are given in the table 2. Now, later on the later stages, when we were a week before the release of the test sets, we also found that the training data has a few false negatives, specifically in the none category. However, because there were no time for making modification in the training data, and also the baselines were also trained on the same data set. So we left the training data sets and we informed the participants about it, and we allowed them to manipulate the data as however they want to optimize their models, as well as in the we also have mentioned that they were also allowed to use the additional data sets, so they could optimize the model accordingly. Now, in the Wiktionary, as I said earlier, there were other distinction as well, such as inherited and borrowed. However, in this data set, we are not maintaining such distinctions, but these kind of distinction are also included in the derivatives form. Also there is one of the things that we need to see, that in our data sets we are distinguishing the languages using the ISO code 639. For example, the new iris ISO GA is different from old iris with ISO SGA. Therefore, new iris with the ISO GA is considered a different language, and the old iris with the ISO SGA is considering two different languages. This kind of differentiation also helps in defining the cognate and the derivatives in a better way, that we have shared in this shared task. For the evaluation of the system, we are using F1 score for supervised classification, and for the unsupervised, we are using the accuracy. Now, for the supervised system, our baseline is trained on multi-layered LSTM network, which has basically two steps. So the data pre-processing steps, where the punctuations and the undesirable Unicode were removed, and each of the words cases were converted and to the lower case basically. And there were also building of the one-hot vectors for both the word and the language information. Now, when we are training the model, so basically we're giving the input, the one-hot encoding as the input with the matrix of 34 into 50, where 34 represents the number of language and 50 represents the buffered word size. We also train the models on the RNN model, and which have 100 LSTM cells with only one single dense layer and softmax activations, and we also uses the Adam optimization and categorical cross entropy to calculate the loss. So the model was set to train on for 250 epochs. But we also stopped at, but the best result was given on the of around 90 to 100 epochs. So we stopped for the last experiment. The best result we got at 92 epochs, and that is what we are using as the baseline. For the unsupervised baseline, we use a simple Levestin edit distance model, which were trained to perform the clustering task with the cluster set of 3. Now, coming to the system submitted for the share task, there were actually 9 teams registered for the task, but only 2 teams submitted for share task and 1 team submitted for unsupervised task. The first team that submitted was the team Kotuhali, led by Livniudinu from University of Bucharest. For their supervised system, they trained a stackable assemble supervised classifier, which is based on SVM, naive Bayes, and SJD. They use the 3 main features as the feature set to train this classifier: graphic, phonetic, and language. However, for the unsupervised system, they are using k-means algorithm with the same set of feature set: graphic, phonetic, and language modeling. The second team, which is the team UFAL, led by Thomas Limestwick from Charles University, submitted only for the supervised task, and the system is based on gradient boosted pre-classifier. The classifier trained on both linguistic and statistical features, which include language model embedding and typological information. The typological features include language identity, language group identity, and orthographic information. Now, moving to the results of both the tasks. So basically, team UFAL gave a much better performance from the team Kotuhali, but Both the teams could not beat the baseline in the supervised task, and the F1 score is given in the table. However, for the unsupervised task, Team Kotoheli beat the baseline accuracy with 0.11 with 0.11 score, and so they have improved the baseline basically. Now we can conclude that the all systems that were submitted to the share task provided a reasonable performance. Both the teams came up with interesting results, though they can't beat the baseline for the supervised task. However, the team Kotoheli performed much better than the baseline for the unsupervised task. Now, we could also conclude that the non-neural training could provide good results with the selected feature set, and we can really optimize with different feature set to good better results. Sometimes a better results for the non-neural better than the neural network system, specifically for the cognate and derivative detections. Thank you. If you have any question, you can ask. Thank you so much.